Let's do, actually, I'm going to pick, I'm gonna go up here, down, across, and around. So I have 12. Coming down here, going across my 4, minus 4d. Cruising along, minus 6e equals 0. The biggest mistake that I see students make at this point is they forget the equal sign in there. They don't actually write an equation. And what do we have? I have 6 equations and 7 unknowns. Well, I do have one other piece of information. I know the potential drop across. Oh, do have another loop. Because that splits. I have a loop right there. There we go. So let's take a loop here. I'm going to start here and I'm going to work my way clockwise. The reason I'm going clockwise is because that's what I typically do. You could go counterclockwise, absolutely no problem. So if I'm starting here going clockwise, I'm going across my 1 ohm resistor in the direction of my current A. And so minus 1A. Then I get around here and I'm cruising all across the 2 ohm resistor, but I'm going upstream. I'm going against the current that I established, plus 2V, and then I'm back to where I started. I now have 7 independent equations. Any other voltage loop equation can be made from these 4. And so now it's just a matter of how do you solve 7 equations, 7 unknowns. So, you are all Calc 2 and beyond. How do you solve 7 equations, 7 unknowns?
Find one of the variables.
Say it again.
Find one of the variables.
Okay, and then what? Okay. So you're just basically solve what you can and see what you get?
Yeah.
All right, so one technique, we can do that. So from this one right here, we can find F. So F is equal to 12/5 amperes. Just recognize this A and that A are not the same. All right, so we have F, so we can make that substitution there. Now what?
For E,
In which equation?
the bottom equation.
Okay, so from this one, we get B is equal to 1/2 A.
And plug it into the A plus B.
So this one right here,
Yep.
so we end up with 3/2 A equals C.
Maybe you should get rid of that A, because I feel like that's gonna get confusing. The amps.
Oh.
Amperes.
Do like a lower basic.
IT looked deep into our souls and said, that room deserves a board that doesn't quite work well. Is that what you're, when you say get rid of the A? All right. All right, so I have B in terms of A and I have C in terms of A. So I can just go through and make those substitutions, get rid of all my C's and B's. So now I'm down to Well, I assume you have all the answers written down, but, if we keep that part, get rid of all this. So my first equation over there still is E plus F equals G. My second equation, we can get rid of our C, so that's 1.5A plus D equals E. Then we have, well, we're implementing the 1.5A equals C. Then we know F is 2.4. Next equation, we got 12 equals, I'm just gonna throw the other stuff to the other side, A minus 3C, which is 4.5A, minus 6E. No, sorry, this would be plus when I take it to the other side. Which is 5.5A plus 6E. And then I have 12 equals 4D plus 6E, 4D plus 6E. And that last one we've already employed. All right, so I have we lost an equation. Because I have 6 unknowns. No, I should have 5 unknowns. I should have 5 equations. So we got E plus F equals G, 1.5A plus D equals E. That one right there. We use those two. Oh, F is one of my unknowns. So this is 2.4. There we go. Now what?
Maybe solve for E.
Okay, which one do you, well, we solved for E right there, so plug it in from that. So we now have 1.5A plus D plus 2.4 equals G. That's what we're using, so now we have 12 equals 5.5A plus 6 times 1.5A plus D. And 12 equals 4D plus 6, 1.5A plus D. That doesn't really simplify any more than that. This one becomes 12 equals, I got 5.5A and 6 times 1.5, so that's 9. So I got 14.5A plus 6D. And then down here, I have 12 equals 9A plus 10D. So A, D, and G. We're down to 3 unknowns.
Solve for A.
Which equation?
Maybe the bottom one.
All right. Might I suggest we solve for D? Because the coefficient's 10, and when we divide by it, we're still dealing with, I don't have to deal with fractions. If you're okay with that.
That's fine.
So if we solve for D here, so I got 12 minus 9A equals 10D. So D equals 1.2 minus 0.9A. So I can now take that, substitute that into this equation and that equation. So I get 1.5A plus 1.2 minus 0.9A plus 2.4 equals G. And plug into this one, and I got 12 equals 14.5A plus 6 times 1.2 minus 0.9A.
Wait, Dr. Fox, could we have multiply the bottom equation by 6 and then top by 10, so you can cancel out the D, and then solve for A instead.
So multiply the, you're talking this equation here?
Yeah, by 6 and then the top by 10.
Would you rather do that? There are many ways of solving these. So, I call that, this is substitution in essence here. The other method I generally call solving simultaneously. So we should get the same thing either way. So if I do this one by, that one by 10 and that one by 6,
Not yet, the one right below it.
that one here,
Yeah.
multiply that by 6, that by 10. We could just adjust it slightly if we multiply this one by 3 and that one by 5. Then we can still get the D's cancel out.
Yeah.
But there's no harm in what you suggested. So if I multiply the top one by 10, I get 120 is equal to 145A plus 60D. I'm gonna multiply the second one for whatever childhood scars there are. I'm gonna multiply this by a -6 so that all I have to do is add them. For some reason, I find adding a positive and negative is easier in my head than subtracting. So that becomes -72 equals -63A minus 60D. And now we add them. Those cancel out. If we'd done it the way that Sarah had suggested, we would be subtracting them instead of adding the negative. This becomes 82A, and this is 48.
Was that 14.5 or 100.5?
I multiplied this by 10, that's 14.5.
Oh,
Going to multiply it by 10, I got 145. Right, did I make an error?
No.
And so A is 48/82, which feels like it's somewhere around 0.52752. I hope
0.5853.
0.5853.
6.
So either we have a Carol's error somewhere, or that's just a little bit off. Actually, that's more off than I would expect. I think there's Carol's error somewhere. So that's going to be the same. So E, so we have a value for A. We can find D now. All right, let me just double check this. So six times 1.5 is 9. 9 and 5.5 is 14.5. So if A is 0, D is 2. No, I'm just gonna do the same thing, doesn't really do much. Here, so I'm feeling decent about that step. So that's 4 and 6 is 10, and then I got 9A, so that step seems legitimate. All right, I suspect there's a careless error somewhere. And this is a decision that you make when you're doing a test and you suddenly have something like this and you realize there's a mistake somewhere. How much time does it take to actually find the mistake? It's a path to madness or a path to incredible satisfaction. Depends on if you find it or not. It is frustrating though. All right, I think you got the general idea of solving it. What I'm going to do next is to look at simpler 3 equations, 3 unknowns. There is a simpler way of actually doing this that you may or may not know how to do. I don't know how to do it with your calculators. But I'm going to take these equations here and I'm going to reorder them so that I have all the A's lined up, all the B's, C's, D's, and so forth, and constants on the other side. So this one right here, this would be, I don't need that anymore. So get rid of those. So we're gonna have my So I'm gonna have my A, B, didn't give myself enough room there. A, B, C, D, E, F, G equals constant. So my first equation, 0 plus 0 plus 0 plus 0 plus 1E plus 1F minus 1G, those are ones, equals 0. The next one, I've got 0 plus 0 plus 1C plus 1D minus 1E plus 0 plus 0 equals 0. Then I have 1A plus 1B minus 1C equals 0. That one down there, those are all zeros, not until we get to F. I have 5F equals 12. And then here, I'm gonna bring all that stuff over, so I got 1A plus 3C plus 6E equals 12. 4D plus 6E equals 12. And then negative 1A plus 2B equals 0. By setting up like that, we now, matrices. How many of you dealt with matrices? Matrix multiplication? 2 of you? 2.5? Sarah? What's your matrix background?
Not really.
Okay. If I look at the coefficients, all I'm going to do now is just write down the coefficients here. So my A coefficients are 0, 0, 1, 0, 1, 0, negative 1. So 0, 0, 1, 0, 1, 0, negative 1. I think that's what I did. 0, 0, 1, 0, 1, 0, negative 1. Okay. My B's, 0, 0, 1, and then 1, 0, 0, 0, 2. My C's, 0, 1, negative 1, 0, 1, negative 1. 0, 3, 0, 0. D's, 0, 1, and then a 4 down there, so 0, 1, 0, 0, 0, 4, 0. And then E's, I got 1, negative 1, 1, negative 1, 0, 0, 6, 6, 0. 1, negative 1, 0, 0, 6, 6, 0. All right, and then F's. Okay. F, I've got 1, 0, 0, 5, 0, 0, 0. So 1, 0, 0, 5, 0, 0, 0. My G's. Negative 1, and that's it. All right, the notation, this is matrix notation, so I've given it to you, we're not gonna do matrix multiplication, but I'm setting it up this way for a reason, so A, B, C, D, E, F, G equals, and then my constants. So 0, 0, 0, 12, 12, 12, 0. 0, 0, 0, 12, 12, 12, 0. Okay, assuming I haven't made a careless error, I got the matrices set up like this. This would be the matrix equivalent of my equations over there. Although it's a huge set of numbers here, the advantage is that your calculator is actually designed for dealing with this. You can set in the equations, and I believe you would set it in where you would type in 0, 0, 0, 0, 1, 1, negative 1, 0 into the right place on your calculator, and then you do each row with the last column being the constants. You hit solve, and it does it for you. There should be a document, I think it's under like the review or something like that, that Mike Jones had created about how to use the TI-80 whatevers to do this. The advantage of doing it is that it's a whole lot less work if you do it right. The disadvantage is there's really not that I can do much for partial credit, because basically there's the black box where everything goes in and I have no idea how you got your numbers if you mistype something or anything like that. So the disadvantage is there really is no partial credit for that part of the problem.
Wait, so what function would it be? You take that, the 7 by 7 one, and then the 1 by 1,
The 7 by 1
or 7 by
rows column, so yeah, 7 by 1 and 7 by 7. So, you know what, let me go find it and let's just take a break. Stretch legs. We have no clock in here, but it's 4:24. For all the international fans. The first method that we did works if you got one battery, the resistors can be broken down into series and parallel. The mistake I made with the 152 group is I couldn't remember where a resistor was, and I put a resistor here. Putting a resistor here, I could simplify this a great deal, but